Hello everyone. This is a presentation on Bayesian estimation of product sales. The aim of this project is to predict and compare the sales of products based on capital investment across different media platforms. Advertising showcases products and services seeking to persuade audiences to purchase their products. Businesses today face immense competition in enhancing and influencing their advertising to create awareness, drive sales, maintain market share, and establish their brand identity. The effectiveness of an advertisement or an advertisement campaign in boosting sale of a product is generally hard to measure, as there are plenty of factors that influence these numbers, such as the reach of a platform, kind of audiences it caters to, etc. Bayesian analysis allows the combination of prior information about a population parameter with evidence from information contained in a sample to guide the statistical inference. Hence, it is a reliable method to implement such a complicated analysis. We use multiple regression model to solve this problem. The data that is used is publicly available on kaggle.com and consists of 200 experiments. There are three predictors, namely YouTube, Facebook, and newspaper, that consist of advertising budget across each of these platforms, and dependent variable being sales that depicts the overall sales obtained. All these values are in thousands of dollars. To understand our data, we implement various statistical calculations and visualizations. As evident from statistical analysis of data, YouTube has a negatively skewed distribution as mean of the data is less than median, whereas Facebook and newspaper are positively skewed as mean is greater than median. Understanding the individual relationship of dependent variable sales with the independent variables with the help of scatter plots, we observe that there is a linear relationship between YouTube budget and sales. This is not the case with other two media. This means that the more capital is invested in YouTube, higher the sales, but higher investment in Facebook is less likely to guarantee a boost in sale. This factor is even worse in case of newspaper. Now we study the dependent variable sales to determine the error distribution. As seen from the density plot, the distribution resembles normal distribution but is slightly skewed towards right and has a tail moving towards infinity. Also, the values are between minus infinity to plus infinity. The data was pre-processed and box plot was plotted to find and remove outliers. There was found a positive correlation between the predictors, which shows that a better analysis could be drawn by handling each predictor individually. The expert information that we have on this data is as follows. For YouTube, every $1,500 increase in budget increases the sales by $1,000. This is a very strong expert knowledge. For Facebook, we do not have any expert knowledge. For newspaper, every $1,500 increase in budget increases the sales by $500. This is a weak expert knowledge. The mathematical model we fit is highlighted here. According to the distribution of sales, we assume two error distributions, gamma and normal. After assuming both these error distributions, we can evaluate the model performance by checking goodness of fit and see which one works best for this data. To implement this, we use JARGS and draw JARGS model diagram and implement that in code. We will include all these informations in our final report due to the slide restrictions. The models are still under testing as we test different values of saved steps, burn-in steps, and thinning steps. But we display a sample of some results that we have obtained until now. The posterior distributions displayed here are obtained from gamma normal model. The MCMC diagnostics for beta norm are shown. Evidently, shrink factor is less than 1.2. Chains overlap appropriately. Overlapping in density plots and HDI limits can be improved by increasing thinning steps and saved steps. Autocorrelation is minute and estimated sample size is large. Standard error is very low. Hence, these diagnostics are more or less reliable and the predictions can be trusted. Our future plan is to implement both gamma normal and normal normal models with different sets of MCMC settings and obtain and report the final results along with the time taken for model constructions in JAGs along with the JAGs model diagrams. In our final results, we will display the approximate mathematical formula which can be used to calculate the sale price given the predictor values for future analysis. Thank you.